Hi, welcome to my video on finding the domain and range of non-linear relations. The previous videos were finding the domain and range of linear line, but now let's look at the non-linear. Could be parabola, could be absolute value, could be anything at all, but I kept it easy. I kept it simple to explain because I didn't go into some of the more complicated ones with asymptotes and things like that. So make sure you understand what's happening. Let's start. Domain is the values of x. The range are the values of y. That's the same no matter what graphs you have, what if you're doing logs, you're doing exponentials, you're doing quadratics, parabolas, absolute values, no matter what you're doing, what topic you're doing, domain is always the x values, range is always the y. And a little trick, the ordered pair is x, y, and D and R, D before R in the alphabet, X before Y. And that's the tip that I use. And we're going to graph with x and y belong to the real numbers. Here we go. If you look at the ordered pairs, non-linear, if you plotted these on a graph, you would find that they would be separate, and I'll show you that now in a minute. But the domain is the x values, which is 1, 2, and -1. And the range is the y values, which is 3, -1, -2. So that's the same as with a linear. But again, graph these on a grid, and you'll see that you can't have a line passing through all 3 points. So it's that's why I call it nonlinear. Notice that these points are nonlinear. So here, the x value, the domain is the x values of those points. So x is -2. And this point, x is 0. And for this point, x is 2. And the range is the y values. And the y value for this point here, let's take the slowest one. That's a -1. And the next point that we have is 2 of them are the same, y value of 1. But we don't have to repeat them. Once we say y is 1, that means we include both of them. C. Now you can see this is nonlinear, made up of 2 segments. Domain and the range. Domain are the values of x in this grid. So the values of x start at -2. Start at -2, and they go all the way over to a 2. So all the x values that's in this graph are from -2 to a 2. So there's -2 to a 2, and x is in the middle, less than, because I always go from the smallest to the largest. The -2 is a solid dot, so it's a bar, and the 2 is a solid dot, so it's another bar. So that's the inequality that represents it. And if you do interval notation, then you have -2 to a 2, and because they're both included, we put a square bracket on both of those. The range are the y values that's in this graph, and the y values go from here to here. You can see the y is -3 is the smallest one, and the largest one go all the way up. Y is 2. Y is in the middle. I go less than, because -3 is less than 2. I use 2 less than symbols. And this is 2 solid dots. So there's a bar, meaning they're equal. And so -3 is less than or equal to y, less than or equal to 2. And so again, that's -3 and a 2. And they're equal, so it's square brackets to indicate that they're included. D. Domain and range. Let's see, domain and range. Again, domain is the x, so the x values go from -2 all the way over, all the x's of 1 and 0, and -1, 0, 1, 2, 3, and it stops at 4. X is in the middle, and less than, and 2 is solid, so it's an equal sign, and the 4 is solid, so it's an equal sign. So that's the inequality, and so it's a bar, -2, 4, and a bar, because they're included. And the y values go from, the lowest is -2, and it goes all the y values, -1, -1/2, 0, 1, 2, 3, up to 4. So it goes to 4, and that's a y, and again I use less than because I go from the smallest to the largest, and these y values are included, so they're equal signs. So -2 is less than or equal to y, less than or equal to 4, and that's the inequality. And so that's a -2, 4 in the interval, and they're both solid, both square brackets, because they're included. Okay, more examples. Nonlinear. This is a part of a graph that you'll see later on, but again, I'm just giving you extra examples, and I'm giving you one that you can recognize. Not that you recognize the figure, but you will recognize how to derive the domain and range from each of these. Because some of them you require grade 12 math, and that's no good to introduce that now. So here we go. This one. The x values in this one, the x's, that's a solid, and that's a solid. The x go from 0 to 2. 0 up to 2, and we go less than. The 0 is included right here, and the 2 is included. So that's inequality, and so it's 0, 2 with the brackets to indicate that they're included. The range is the y's in this graph, and the y's in this graph go from a -3 up to 3. And that's the range is the y's, so less than, and they're included, so it's an equal sign. And so -3 to a 3 with square brackets because they're equal. F, again, different. So domain is the x's, so the x's are going from 0 over 2, 2, 3, over to 4. X is in the middle, less than. 0 is less than x, less than 4. And notice the 0 is a hollow dot, so it's not included, so I don't put a bar there. And this is a solid dot at 4, so the 4 is included. And that's the inequality. And now we got a 0 going to a 4. 0 is not included, so it's a round bracket, arc. And this one is a square bracket. So this one means the 4 is included because it's a solid dot. This one is the 0 is not included. And the y values are going from the y's. The smallest y value is -1, and the largest y value in this graph is as a 1, that's a 2, that's a 3. And that's a y, because y is the range, so we're looking at the y's, less than, and at -1, it's solid, so it's a bar for an equal sign, and the 3 is a solid, so it's an equal sign, so that leaves -1. That's the inequality that represents the range, and -1 to a 3, and both of them are square brackets because the -1 is in the graph and the 3 is in the graph. You might say, well, How about this one? But remember, as long as one of them, right here the 1 is not included, right here the 1 is included. So as long as it's included, if you had 2 hollow dots, one here and here, then you would have to omit the 1. But as long as it's one of them, as long as the graph passes through one of the coordinates, then you're okay. G, we have what we call a parabola, but we'll talk about that later. That's a whole new chapter. But the domain is the x values. Now the x values are going left. Notice that this line or array is moving. As you move to the right, that goes up and up and up. So as you move to the right, the x's go further out. So, and as you move to the left, this goes up and up and up and up, and the x's go negative. So that means that the domain for the x's belongs to the real numbers, because all of the x's, as this graph, as the x goes out and out and out, this graph just keeps going up and up and up. And the same way this way, as x goes out here, this graph keeps going up and up and up. So there's reals, and reals are denoted by negative infinity, comma, positive infinity, and not the square brackets, but the oval brackets. That indicates for interval notation. And the y values in this graph, the smallest one is -1. So the y values are -1 and they go up. So that means y starts at -1 and goes up. So y is greater than, and this is a solid dot, so it's equal to. So it's y is greater than or equal to -1. The y values start at -1 and go up. So going up is greater. And that means you have -1, and it's a box, and square brackets, and you're going up is going to positive infinity if you're using the interval notation. And H, we have a graph that's going up. Notice there's no line here. If you put a ruler on this, this is not linear, because what? There's a line going through this point and this point, but there's other points that's not on that line. So this is what you call a nonlinear. You'll discuss these later on in your math course. But this point right here is x is 1 and y is -3. Okay, that means the x values are starting at 1. X is 1. X values are starting at 1, and the x values are going to the left. So going to the left is less than, and it's a solid dot, so y is less than or equal to 1. All the y values are equal to 1 and less than going to the left. And the notation for that is a 1, and it's equal, so it's a bar graph, box, and going to the left is going to negative infinity. Keep on going over to the left, you go to negative infinity. -10, -50, -100, etc., -1,000, etc., etc. And the range, sorry, that's the x. This is x. X is the domain. So that's x is less than. The range are the y's. So y starts at the -3, and the y starts at -3, and the y is going up. So up is greater than, and it's equal to, because it's a solid dot. So notice the y values are -3, -2, -1, 0, 1. So as you go over and over and over, the y values are going up. And that's the inequality. And so it's equal to, starting at a -3, and you're going to positive infinity. I. Domain for this one is the x's, and the x's is starting at Notice the x is starting at -2 and going to the right. This goes out, so it starts at -2 and it's going to the right, and the right is greater than. So it's greater, the x values start at -2 and is equal to -2. And so that starts at -2 and is equal, so it's a block. And it moves to the right, so positive infinity. And that's an open, because it keeps going on and on. And the y values in this graph, notice the y's, as you leave here, you go up and up and up. So the y values are going to infinity, positive. And when you go down, 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 the y values are going on down to negative infinity. So the y's are belonging to the reals, which means you got a negative infinity going to positive infinity. That's how you write the interval notation for a set of all real numbers. So all the y's, if you could keep graphing this and get a bigger sheet and you put it on a you know, how big can you make it to see that it keeps going on and on and on. Okay, so now we're to what we call practice. Practice is more to do. So this is for you to pause the video and work one at a time and press play to see if you got the right answers. Here we go. The domain is the x, -1, 2, and 3. Or the x is -1, 2, and 3. The y's are 4, 5, and 6. 4, 5, and 6. The same as a linear. Non-linear is the same when you're given ordered pairs. And in this one, the domain is 1, 4, 4. So 1, 4 will do it. 1 and 4. The range is a 2, 2, and 7. So 1, 2 will do it. Okay. Number 3. We got some points. And the domain, we're looking at the x's. So we got these 2 points here, and this one and this one. So the x value here is -3. The x value here is a 1. And the x value here is a 2. That's the domain for these 3 ordered pairs. Again, you got a -3 twice, but only 1 will do. And the range is the y values, and the y values, the lowest one is -2. And the next y value is -1. The next y value on this point is 1. And the next y value for this one is 3. Number 4, we want the domain for this set. So the x's in this set are from x right here is -2 on over to a 3. So x goes from -2 to a 3. X is in the middle, less than, and x is included, so it's a bar. X is -2 is less than or equal to x, and 3 is a hollow dot, so we don't put in there, not included. And the interval notation for that is -2 to a 3 with a box and an open bracket. This bracket means it's included, this one means it's not included, this one means it's equal to. Number 5, we have the graph going sideways. Let's see, all the x's in this are from the x value on these points is -1, and we go on over to a 2. So it's a -1 to a 2. And x is in the middle, less than. And notice -1 is solid, so it's an equal sign. And this is included, so it's an equal sign. So there's the inequality, and so it's a -1 to a 2 with a block brackets because they're included. And the range is the y values, and the y's go from -2 on up to a 3. So -2 to a 3 with the y's. Again, less than, because -2 is less than 3. You got to do 2 less thans. And These are all included, so because they're solid. So there's the inequality, and so it's a 2 negative and a 3 with box, because these square brackets means they're included. Number 6, the domain is the x values, and the x values, so notice that the x values are not, there's no x's up above the 2, like a 3 or a 4 or a 5. So the x values start at 2 and is equal to it and is going down. The x values are 2, 1, 0, negative 1, negative 2, and they're continuing on to go down. So the x is less than is equal to, because that's a solid dot. And the interval for that is a 2, and it's square bracket because it's equal to, and it's going down on, down, 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 so it's negative infinity. And it's an open bracket. The range is the y values, and the y values go on down. They keep going down, 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 down. On this side, the y values. Now, I have, okay, sorry about that. I have the y's. This should be the y's. I made a mistake. I'm talking about the y's going down. The x's here are all of them. Sorry, my mistake. The x's are going down. X's are going all of them to the right. X's of them are going all of them to the left, because it keeps going down and down. So the x belongs, sorry about that, belongs to the reals. I don't know what I was thinking about then. So the reals are negative infinity to positive infinity for all real numbers. Sorry about that. The x's are using all of them. All the x's are being used in the graph. Sorry about that. Number 7. What x's are in this graph? Well, they start at negative 2, 3. X is negative 2, and y is 3 is the point that this is. That x is negative 2, y is 3. So the x's start at negative 2. So x is negative 2. And the x's are swinging to the right, so it's greater than. And it's an equal to because it's solid. There it is. And so that's negative 2. Going to the right is a positive infinity. And that's open. And that's closed because that's a solid dot. The range are y is 3, and the y's are starting at 3 and going down, so it's less than, because a solid dot is equal to. There's the inequality, and that starts at a 3, and it's going down, so it's negative infinity. And it's, notice the 3 is included, so it's a box, and that's an open. Anytime you use infinities, you gotta have a open bracket. And number 8, what values of x are in this graph? Well, again, the x's start at 1 and they're going left. So this time, x is going this way and they start at 1, and x is less than, and there's a solid included. So this dotted point is included. So it's x is less than or equal to 1. And the notation for interval is 1, and it's going to negative infinity. And so this is a square bracket, and this is a bracket, curve not included. And what y's are in this graph? Well, the y's are, as you leave here, the y's are going up and up and up and up. It keeps going up, so that keeps going up there. And as you keep going like this, they keep going down. So the y's are the reals, all the y values. If you drew this graph and made a bigger sheet of paper and bigger, as put it on the floor and kept drawing it, you would cover all the y's. So the y's are reals, negative infinity to positive infinity, open, open. can be a little bit confusing, so you got to be careful. Be careful, you know, when you're doing the X's, start and go one way or the other. When you're doing the Y's, be careful. Just be careful. Brings us to the end. If you like my video, click on the like button, click on the subscribe button, click on the notification bell, and write a comment on my video if you wish, and visit my math website, www.mathfullyexplained. And I got 3 sections. One on me, talks about my degrees and teaching experience. My videos section talks about the strategies you're going to use to help you learn your math. And the content section has the topics and the number of videos on those topics. And what's online now is in black font, and the red font will be there in the near future. Thank you very much. Bye-bye.